In the last sections, I explained how to form a protostars from a molecular cloud. Some materials fall to the central regions and increase the densities. Due to the increased density, the gravity is increasing and the outer regions fall to the centers to form a protostars. When a protostar is forming, also a protoplanetary disk is forming around the protostars. I'd like to explain the formation process of a protoplanetary disk. So we consider gas molecules rotating with a rotational angular velocity of capital omegas. Because of the rotational motions, we consider the specific angular momentums. Specific means per unit mass. So we consider a particle with a unit mass given by the J. Angular momentum is a conserved quantity, so J is conserved during the motion of the particles. Then centrifugal force is given by V squared over R. And J is expressed R times V. So you can substitute V equal J over R. You can substitute here. Then it becomes J squared over R cubed. This is the magnitude of the centrifugal force acting on the particles. The gravity from the inner regions, so F sub G equals Gm over R squares. So if you plot these two forces acting on the particles, horizontal line is a log R and the vertical line is a log F. If you draw the gravitational force because of the 1 over R squares, F sub G is proportional to 1 over R squares. F sub C is centrifugal force. Is proportional to the 1 over R cube. So because of the 1 over R cubes, F sub C is steeper lines. If the particle is moved inner regions, centrifugal force becomes stronger than the gravitational force. Then particle cannot sink directly to the centers. Even if the particle is trying to sink to the centers, at some point centrifugal force becomes stronger than the gravities, then it cannot fall to the centers. Instead, fall in the vertical direction and forming the disk around the protostars. Because this particle is also actually falling to the disk and forming a disk. So without any accurate calculation, we can easily expect the formation of protoplanetary disk around the baby stars. This is the formation process of a protoplanetary disk. Then we'd like to estimate the radius of a formed disk. So we start considering the size of a molecular cloud core. So using the Euler equations. This is the equation for the force balance. So 0 equal pressure gradient minus Gm rho over R squares. Pressure is given by the rho A squares. A is the sound velocities. So you can substitute this pressure is here. Then make an order of estimate. Then P over R. Just only we consider magnitude. Gm rho over R squares. The P is a rho A squares. Then rho is going to be cancelled out in the both sides of the equation. Then you can find the R. R express Gm over A squares. So we use the order of estimate. So nearly equal to the Gm over A squares. Then if you consider the molecular cloud, the temperature is a little bit higher than the 10 kelvins because we only consider the central regions is 50 kelvins. Then size of these spheres becomes 5 times 10 to 3, 5,000 AUs. If you consider temperature is 50 Kelvin. So if you decrease this temperature, size becomes more bigger than this one. So this is much larger than the size of the solar systems. Then we'd like to estimate the specific angular momentums. If you draw the vertical line to the rotation axis, so this length becomes r sine theta. So this particle is making a circular motions around this axis. The specific angular momentum is expressed radius times the velocities. The velocity is given by the radius times the angular velocities. So radius square omega. That's a specific angular momentum. R square omega. This is capital R. So we can substitute. Specific angular momentum is expressed omega r square sine square theta. You can substitute initial size of the core of the molecular cloud, r is here. Then specific angular momentum is given by the omega times the g square m square over a to the fourth times sine square theta. Two forces acting on the particles. One of the force is a gravitational force and the centrifugal force. These two forces are equal. Then centrifugal force is expressed j square over r cube. And the gravitational force gm over r squares. So from this equation, you can find out the radius of the disk is given by this equation. If you consider the angular velocities of a molecular core is 4 kilometers per second per sec. Then you can calculate. This is about the order of the 100 AUs. So compared with the initial size of the 5000 AU to 100 AUs becomes nearly the 2 order of magnitude is decreased. During the formation process of protostars, protoplanetary disk is also be formed with a protostars. We expect a planet is going to be formed inside of a protoplanetary disk. Okay, this is the end of this lecture.